So with example 2, we can get a question like so. Work out the equation of the circle. So what we're given is that our circle is at the origin. We can see that clearly. They won't necessarily need to state that it's at the center. You will need to just look at your picture. If the center of the circle is at the origin, automatically that's a given, right? You don't want to stress too much about it, but they didn't tell us or something like that. So with a question like this, if they're going to ask us to give the equation of the circle, anytime you're asked to give an equation of anything, a function, a circle, you always want to start off with the standard form, right? So in our case, we already know that our standard form for any circle, I'm deliberately writing this format because I would want us to get used to just keeping in mind that this is the equation of a circle, right? The standard form. And then wherever our circle has a center at the origin, the A and the B will just be 0. So just get comfortable with this format because that's the norm really. So we have written out our standard form and we can just go ahead and plug in the values that we already have, right? Because as long as our circle is at the origin, we know that the x value of our center is a 0, the y value of our center is also a 0. So far, this is what we have. Okay, so that was obviously not very necessary. However, as mentioned, I just want us to get very used to just keeping in mind this is the standard form. So far we have subbed in our center and we now need to work out the radius of our circle. So if you think of it, if we're going to work out the radius of our circle, so again, we know that whatever the radius of our circle is, it's going to be a line from the center going all the way to a point that we're given. So this coordinate here, if they're going to ask us to work out the equation of the circle, they would need to at least have given us that coordinate or any other kind of information to help us. So for our radius here, you basically have quite a bunch of options for you to work out the distance here. You can use the distance formula, you can use Pythagoras, it's quite a lot of options. I am going to go ahead and use Pythagoras. However, funny enough, if you use Pythagoras or the distance formula, you're doing one in the same thing, right? So let me go ahead and do that. So when I say using Pythagoras, I mean this is a right angle triangle, right? And this is telling us that the distance from left to right, that's going to be 3. And this is telling us that the distance from top to bottom, that's going to be a 4. So to work out our r, right, we could actually start off by saying r squared is equal to 3 squared plus 4 squared, right? Because this distance here, I can just label it as r, because that's what it is. And then this is giving us 9 plus 16. This is giving us 25. So please note that this is saying r squared is equal to 25. You can go ahead and throw in 25 there. Your answer will still be fine. However, if you want to leave it in standard form, you can go ahead and square root r. This is giving a 5. And then our final answer is going to be r squared plus y squared is equal to 5 squared, right? So we know that our center is a 0, the x value, and then the y value of our center is also a 0, hence why there is no bracket or anything. And then our r value, which is the radius, we also have gotten that to be 5. So this is again another basic example, but we're just gonna carry on, do another one that's slightly a bit more challenging. Okay, so before we dive into something a bit more aggressive, these kinds of basic questions, right, we would also want to be able to do that. So for example, with an equation given as such, this is an equation of a circle. It's likely in standard form, and they're asking us to work out the center of the circle. Goodness, right? And then they're asking us to work out the radius of the circle. So for the first question that we're given, right, we already know that if they're asking us for the center of the circle, that's in our standard form, right? It's going to be our value 2, not -2. We always take the opposite, and we always take the opposite of the y value of the center. So the center of our circle is going to be 2 coordinate -3 because we always want to get the opposites of what these two values are. So that's the center, right? Bluntly speaking. The second question that they've asked us, we know that if we're going to get the radius of our circle, we would not want to say our radius is equal to 25. That's wrong. The reason is this equation, it is in standard form. However, we cannot clearly see what our R value is. So we can almost even say it's not 100% in standard form, right? So if we're going to get R, we want to take this value here, and we want to get the square root of that value, right? So the reason why you want to get the square root of this value is, if you look at what goes in this position in our standard form, we know that what goes in this position is R squared, right? So in the place where R squared goes, we have the value 25. So if we want to work out what R is in this position, we square root both sides, right? That's how I say it here. R is just going to be the square root of 25. So for our second question, right, what is the radius of our circle? The radius of our circle is just going to be 5.